In 1973, a radio astronomer named John Ball published a paper. It was in the journal Icarus. It was not a long paper. It was only a few pages, but the idea inside it was huge. He proposed something called the zoo hypothesis. The idea is simple, and it is a little creepy. It says that alien civilizations might be out there, and they might be very advanced. They know we are here, but they have decided not to contact us. They are intentionally staying hidden. They are watching us. Ball suggested they observe us like we observe animals in a zoo or a wildlife preserve. We are the exhibits. This idea tries to solve a big problem called the Fermi paradox. The paradox asks, if the universe is so big and old, where is everybody? The zoo hypothesis says they are here. They are just being quiet. They are watching. This creates a kind of cosmic illusion. The illusion of an empty universe, an illusion of being alone. We point our most powerful telescopes at the sky, and all we hear is silence. All we see are stars and galaxies following the laws of physics, but according to this idea, the silence is deliberate. The emptiness is a mirage. The greatest trick might not be a bent ray of light or a cloud of dust. It might be the perfectly convincing performance of an empty stage put on by an audience that we can never see. Number 17, some stars are imposters in their own neighborhoods. A globular cluster contains hundreds of thousands of stars. They are all supposed to be born around the same time. This means they should all be old. In astronomy, big, hot blue stars burn out fast. Or old star clusters should not have any of them, but they do. In 1953, astronomer Alan Sandage was looking at the globular cluster M3. He saw stars that were much bluer and brighter than they should be. They looked young and hot, but they were living in an ancient neighborhood. He called them blue stragglers. For decades, nobody knew what they were. They were an illusion. They tricked us into thinking a star was young when it was actually ancient. It breaks the rules of stellar evolution, at least the simple rules. These stars did not form later than their neighbors. That was one early theory, but it did not fit the evidence. The truth is more complicated and involves a kind of stellar vampirism or collision. One way to make a blue straggler is for two old stars in a binary system to get too close. One star, a red giant, puffs up its outer layers. The other star, a smaller companion, starts pulling that material away. Its gravity strips gas from the bigger star. This stolen gas makes the smaller star more massive. More mass means more pressure in its core. More pressure means it burns hotter and faster. It turns blue, it looks young again, it has been rejuvenated with stolen fuel. It's a straggler because its evolution has been delayed compared to its neighbors. Another way is a direct collision. Globular clusters are very crowded places. Stars can and do run into each other. If two old, small, reddish stars smash together, they can merge. The combined object has more mass than either of the originals. It will burn hotter and bluer. It becomes a blue straggler. The Hubble Space Telescope has seen evidence for both of these processes. It looked at the core of the globular cluster 47 Tucanae and found blue stragglers that were twice as massive as the other stars. This points to mergers. It also found blue stragglers with low amounts of carbon and oxygen, which is what you would expect if they had their outer layers stripped off by a companion. So the illusion is one of age. We look at a star's color and brightness to guess its age. Blue means young and hot. Red means old and cool. Blue stragglers are a lie. They are old stars masquerading as young ones. They are the cosmic equivalent of a senior citizen who has found a fountain of youth by stealing life from their neighbors. This discovery forced astronomers to rethink how stars interact in dense environments. It showed that stellar evolution is not always a lonely path. Sometimes it is a violent interactive process that can create stars that should not exist. They are not just curiosities. The number of blue stragglers in a cluster can tell us how dynamically old the cluster is. A cluster with many blue stragglers has had a lot of time for its stars to interact and collide. They are a clock, but a strange one. They tell time by counting the number of stellar car crashes and thefts. Number 16, seeing the echo of a dead star's final scream. A star explodes. It is called a supernova. The light from that explosion travels out in all directions. It is a sphere of light expanding at the speed of light. Now imagine there is a big cloud of dust in front of the star, but off to the side. Some light from the explosion travels directly to our telescopes on Earth. We see the supernova flash and then fade. But other light from the explosion travels sideways. It hits that dust cloud. The dust reflects the light like a mirror or a fog bank. This reflected light then travels to our telescopes, but it took a longer path. It had to go from the star to the dust and then to us. That detour takes time. So we see the original supernova, and then months or even years later, we see a ring or a blob of light appear around it. This is a light echo. It is the ghost of the original explosion, still traveling through space. The illusion here is bizarre, because the light is hitting parts of the dust cloud that are progressively farther from the star. The ring of light we see appears to expand. And because of the geometry of the light paths, this expansion can appear to move faster than the speed of light. In 2002, a star called V838 Monocerotis suddenly brightened. The Hubble Space Telescope watched it. Over the next few years, it saw an incredible expanding shell of light illuminating the dust around the star. At times, this shell appeared to grow at 7 times the speed of light. This is called superluminal motion. But nothing was actually breaking the cosmic speed limit. It was a trick of geometry. We are seeing a pulse of light sweeping across a stationary dust cloud. It is like a laser pointer dot moving across a wall. The dot can move faster than the laser itself, but no object is actually moving that fast. Light echoes are incredibly useful. They are a form of cosmic archaeology. The original supernova might have happened hundreds or thousands of years ago. The direct light from it passed Earth long before we had telescopes, but the echoes are just arriving now. By studying the light from the echo, we can study the spectrum of the original, long-gone explosion. We can figure out what kind of star exploded. This is what astronomers did with the supernova that created the Cassiopeia A remnant. The explosion happened in the late 1600s, but it was not widely observed on Earth. However, by studying its light echoes off nearby dust clouds, astronomers in the 2000s were able to classify the type of supernova it was. They performed an autopsy on a star that died over 300 years ago using its ghost. These echoes also map the dust clouds in 3 dimensions. As the light pulse travels outward, it illuminates different layers of dust, and it is like a cosmic CAT scan. We can see the structure of the interstellar medium in a way that is normally impossible. We can see clumps and voids in the dust that are otherwise invisible. So this mirage, this illusion of faster than light travel is not just a curiosity. It is a powerful tool. It lets us look back in time. It lets us, map the invisible. And it shows us that even the final flash of a dying star can have an afterlife, a ghost that continues to travel the cosmos long after the star itself is gone. Number 15, the universe has an invisible wall in it. When we look out at the universe, we see galaxies. They are not spread out evenly. They are clustered together in filaments and walls, separated by vast, empty spaces called voids. In 2014, astronomers were mapping out a region of space. They discovered something enormous. It was a supercluster of galaxies, a massive collection of galaxy clusters. They named it the Laniakea supercluster. Our own Milky Way galaxy is part of it. It is about 520 million light years across. But what was more interesting was how they found it. They did not just look at where the galaxies were. They looked at where they were going. They measured the velocities of thousands of galaxies. They found that a huge region of space, containing about 100,000 galaxies, was all flowing in the same direction. It was all moving towards a single point. This point is called the Great Attractor. It is a gravitational anomaly. It is a huge concentration of mass that is pulling our galaxy and thousands of others towards it. The problem is, we can't see it very well. It is located in the direction of the constellation Norma. This part of the sky is obscured by the dust and stars of our own Milky Way's disk. This is called the zone of avoidance. Our own galaxy creates a mirage, a blind spot that hides one of the most massive structures in our local universe. The Great Attractor itself is not an illusion. Its gravitational pull is real. We measure it in the motion of galaxies. It has a mass of about 10 quadrillion suns. That is thousands of times more massive than the Milky Way. But its appearance, or lack thereof, is deceptive. For a long time, astronomers could not figure out what was causing this immense pull. The galaxies they could see in that direction did not have enough mass to explain it. This led to all sorts of theories. Was it a bizarre concentration of dark matter? Was it something entirely new, more recent observations using X-ray and infrared telescopes that can see through the Milky Way's dust have started to solve the mystery? They found a massive galaxy cluster right in the heart of the Great Attractor region. It is called the Norma Cluster. It is very massive, but even it is probably not massive enough to account for the entire pull. The full answer seems to be that the Great Attractor is not a single point. It is a broad region of high density, with the Norma Cluster at its center. And even beyond that, another even more massive structure called the Shapley Supercluster is also pulling on us from a greater distance. So the illusion was twofold. First, our own galaxy hid the culprit from us for decades. Second, we were looking for a single giant thing. But the reality is a more diffuse, spread out concentration of mass. Oh, it is not a single object, but a whole gravitational valley that we are sliding into. Our entire local group of galaxies is moving towards it at about 600 kilometers per second. That is over 1.3 million miles per hour. We are being reeled in by a cosmic ghost, a structure that was hidden behind a curtain of our own making. And it is a reminder that even our home galaxy can trick us, creating blind spots that hide the true nature of the universe. Number 14, our planet's air creates phantom green lights and shifting stars. The most common cosmic illusion is one we see every night. Stars twinkle. It looks beautiful, but it is a complete mirage created by our own planet. A star is a point of light. As its light travels through the last few dozen miles of Earth's atmosphere, it gets distorted. The atmosphere is not uniform. It has turbulent cells of air with different temperatures and densities. These cells act like little lenses. They bend the starlight back and forth very quickly. To our eyes, this makes the star's position seem to jitter and its brightness seem to flicker. That is twinkling. Planets, on the other hand, do not usually twinkle. This is because they are closer. They appear as tiny disks, not points. The light from different parts of the disk gets distorted in different ways, but it all averages out. The twinkling gets canceled. This is a simple way to tell a star from a planet in the night sky. This atmospheric distortion is the enemy of astronomers. It is called seeing. On a night with bad seeing, the atmosphere is very turbulent. Star images in a telescope look like blurry, boiling blobs. This is why major observatories are built on high, dry mountains. They want to get above as much of the thick, turbulent air as possible. The Hubble Space Telescope, of course, avoids this problem entirely by being in space. That is its biggest advantage. It is not bigger than the largest ground-based telescopes. It just has a perfectly clear, non-twinkling view. A more dramatic illusion caused by the atmosphere is the green flash. This is a real phenomenon, not a myth. It happens very briefly at sunset or sunrise. Just as the last sliver of the sun's disk is disappearing below the horizon, it can flash a brilliant green color for a second or two. This happens because the atmosphere acts like a prism. It splits the sunlight into its different colors. The red light is bent the least, and blue and green light are bent the most. When the sun is very low on the horizon, its light has to pass through a lot of atmosphere. This prism effect separates the colors, creating slightly different images of the sun in each color, stacked on top of each other. The red image is lowest, and the green-blue image is highest. As the sun sets, the red and yellow images disappear first. For a moment, only the very top sliver, the green part, is visible before it too sets. Blue light is scattered away by the air molecules, which is why the sky is blue, so we are left with a brief green flash. The Mirage, the green sun, is not real. It is an image created by our atmosphere acting as a lens. These atmospheric tricks have fooled people for centuries. They can make the moon look huge on the horizon, the moon illusion, which is actually a psychological trick, not an atmospheric one. They can create mirages of water in the desert, and for astronomers, they are a constant source of frustration. So modern telescopes use a technology called adaptive optics to fight back. They shoot a laser into the sky to create an artificial star. A computer measures how the atmosphere is distorting this artificial star's light. It then adjusts the shape of a flexible mirror in the telescope hundreds of times per second. This cancels out the atmospheric twinkling. It is an incredibly complex way to undo a simple illusion, allowing telescopes on the ground to get views almost as sharp as those from space. Number 13, a perfect cosmic smoke ring that shouldn't exist. In 1950, an astronomer named Arthur Hoag found something strange on a photographic plate. It was a galaxy. But it looked like nothing he had ever seen before. It was a perfect ring of young hot blue stars. This ring surrounded a much older yellow core. In between the ring and the core, there was almost nothing. It was a dark gap. The object was named Hogg's object. It is about 600 million light years away. For a long time, it was a complete puzzle. It looked like an illusion, something that could not have formed naturally. A perfect ring is not a typical galaxy shape. We have spiral galaxies and elliptical galaxies. This was something else. The illusion of Hogg's object is one of perfection and simplicity. It looks like a simple, elegant structure, but its formation must have been complex and violent. How do you make a galaxy like this? There are a few theories. One idea is that it was a collision. A small galaxy might have passed right through the center of a larger disc-shaped galaxy. This cosmic bullseye would have created a ripple effect, a density wave that expanded outwards. As this wave moved through the gas in the disk, it would have triggered a burst of star formation. This would create the blue ring we see today. The problem with this theory is that we do not see the other galaxy. The bullet galaxy should be somewhere nearby. It is not. Maybe it was a very long time ago and the other galaxy is too far away to be identified. Another theory is that it was a bar galaxy, a type of spiral galaxy with a central bar-like structure. Over billions of years, the bar could have become unstable and broken down, with its stars and gas settling into a circular ring. This is a slower, more graceful process, but it is hard to model and prove. The core of Hogg's object rotates at a different speed than the ring, which adds another layer of complexity. What makes this object even more bizarre is that if you look closely at images from the Hubble Space Telescope, you can see another, much more distant ring galaxy right through the gap in Hogg's object. It is a cosmic coincidence, a 1 in a million alignment. It is like seeing a wedding ring with a smaller wedding ring perfectly framed inside it. Hogg's object forces us to question our models of galaxy formation. It shows that there are outcomes we did not predict. Less than 0.1% of all known galaxies are Hogg-type galaxies. They are incredibly rare. They are a beautiful, mysterious illusion. They look designed like a piece of cosmic art, but they must be the result of natural, if unusual, physical processes. Every time we find an object like this, it is a piece of a puzzle. It tells us that our understanding of how galaxies evolve is incomplete. There are pathways for galaxy formation that we are only just beginning to understand. It is a perfect circle that reminds us that the universe is more creative and strange than we can easily explain. Number 12. Space itself bends light, like a magnifying glass. In 1919, Arthur Eddington took a trip to the island of Principe off the coast of Africa. He was there to watch a total solar eclipse. His goal was to test a radical new idea from Albert Einstein called general relativity. The theory said that massive objects warp the fabric of space-time, and that this warped space should bend the path of light. During the eclipse, the sun's light would be blocked, allowing Eddington to see the stars near it. If Einstein was right, the gravity of the sun should bend the light from those distant stars as it passed by. The stars would appear to be in slightly different positions than they normally were. Eddington took his photographs. He measured the positions, they had shifted. The amount of the shift was exactly what Einstein's theory predicted. It was the first confirmation of one of the most profound ideas in science. This phenomenon is called gravitational lensing. The gravity of a massive object like a star, a galaxy, or a cluster of galaxies acts like a lens. It bends and magnifies the light from objects that are behind it. This creates some of the most stunning and deceptive illusions in the entire cosmos. Sometimes a single distant quasar can be lensed by a galaxy in front of it. The lens can create multiple images of that one quasar. In 1979, astronomers found the twin quasar. It looked like two identical quasars sitting side by side, but their light signatures were exactly the same. It was one quasar with its light being split into two paths by an intervening galaxy. Sometimes the lensing is even more dramatic, creating four images in a cross shape known as an Einstein cross. The illusion is that we see multiple objects where there is only one. This can mess up our counts of distant galaxies and quasars if we are not careful. But this illusion is also an incredibly powerful tool. The way the light is bent tells us about the mass of the object doing the lensing. This is one of the primary ways we see dark matter. We cannot see dark matter directly, but we can see the gravitational lensing it causes. When we look at a cluster of galaxies, the amount of lensing is far too great to be explained by the visible stars and gas. There has to be a huge amount of invisible mass there. By mapping the distorted shapes of background galaxies, we can create a map of the dark matter in the foreground cluster. We are seeing the ghost by the shadow it casts. Gravitational lensing also acts as a natural telescope. The lensing effect can magnify the light from very distant objects, allowing us to see galaxies that would otherwise be too faint. The Hubble and James Webb space telescopes use massive galaxy clusters as gravitational lenses to peer back to the very first galaxies that formed in the universe. The cluster's immense gravity collects and focuses the light from these early galaxies, making them bright enough for us to study. In 2022, Hubble used this technique to find a star nicknamed Earendel. It is the most distant single star ever detected, seen as it was just 900 million years after the Big Bang. We could never have seen it without the help of a cosmic mirage. So this illusion, first proven during an eclipse over a century ago, has become one of our most important instruments for exploring the invisible and the ancient universe. Number 11. The red color of space is a lie. When we look at distant galaxies, they look redder than nearby ones. This is due to the expansion of the universe. As a galaxy moves away from us, the light waves it emits get stretched out. This stretching shifts the light towards the red end of the spectrum. This is called cosmological redshift. It is the primary way we measure cosmic distances. The redder a galaxy is, the faster it is moving away from us, and the farther away it is. But there is another effect that can also make things look red, and it has nothing to do with distance. It is a cosmic illusion caused by dust. Space is not empty. It is filled with a thin medium of gas and dust. This is the interstellar medium. When light from a star travels through a cloud of this dust, it gets scattered. The dust particles are very small. They are more effective at scattering blue light than red light. Well, blue light has a shorter wavelength and it interacts more with the tiny dust grains. Red light has a longer wavelength and can pass through more easily. The result is that some of the blue light is scattered away from our line of sight. What is left is light that is dimmer and redder than when it started. This is called interstellar reddening or extinction. It is the same reason a sunset looks red. When the sun is on the horizon, its light is passing through a lot more of Earth's atmosphere. The atmosphere scatters away the blue light, leaving the reds and oranges. This reddening is a huge problem for astronomers. It is a mirage that can trick us in several ways. First, it can make a star look cooler than it actually is. A hot blue star can look like a cooler yellow or orange star if its light has passed through a lot of dust. This can lead to misclassifying stars. Second, it can make us misjudge distances. We often use a star's color and brightness to estimate its distance. If we see a star that looks red and dim, we might think it is a faint, distant star. But it might actually be a bright, nearby star that is heavily obscured by dust. The dust is creating the illusion of distance. Astronomers have to carefully correct for this effect. They do this by measuring the star's light at different wavelengths. They know the expected color of a certain type of star. By comparing the observed color to the expected color, they can calculate how much reddening has occurred. This allows them to figure out how much dust is in the way and what the star's true color and brightness are. The James Webb Space Telescope is particularly good at dealing with this problem. It observes in infrared light. Infrared light has an even longer wavelength than red light, so it can pass through dust clouds almost unaffected. This is why Joust can see stars forming inside dense, dusty nebulas, something that is impossible for a visible light telescope like Hubble. So, when we look at a beautiful, colorful image of a nebula from a telescope, we have to remember that some of that color is a lie. The deep reds are not always from old, cool stars. They are often the result of interstellar dust acting as a filter, tricking our eyes and our telescopes. It is a constant battle for astronomers to separate the true properties of an object from the illusions created by the space between us and it. Number 10, some things in space appear to break the speed of light. In the 1970s, astronomers were using radio telescopes to look at quasars. Quasars are incredibly bright objects at the centers of very distant galaxies powered by supermassive black holes. They often shoot out massive jets of plasma at incredible speeds. When astronomers looked at some of these quasars, like one called 3C273, they saw something that seemed impossible. They saw blobs of gas in the jets moving away from the central black hole. They measured the movement over several years. When they calculated the speed, it came out to be 5 or 10 times the speed of light. This was a direct contradiction of Einstein's theory of special relativity, which states that nothing can travel faster than light. It was a cosmic illusion of the highest order. This phenomenon is called superluminal motion, and it is a trick. It is not real. Nothing is actually breaking the cosmic speed limit. It is an illusion created by a combination of high speed and a specific viewing angle. Here is how it works. Imagine a jet of plasma being shot out from a quasar. It is moving very fast, maybe 99% the speed of light. And it is pointed almost directly at us, but just slightly off to the side. Let's say the jet emits a pulse of light at point A. This light starts traveling towards us. The jet itself continues to move forward. Sometime later, it reaches point B and emits another pulse of light. This second pulse also travels towards us. Now, because the jet is moving so fast and almost directly towards us, it has chased its own light. The distance between point A and point B is much larger than the distance the light from B had to travel to catch up with the light from A. To us on Earth, it looks like the two light pulses arrived very close together in time, but the source that emitted them actually moved a very large distance across our line of sight. When we calculate the speed, we divide the apparent distance it traveled across our view by the apparent time it took. Because the apparent time is so short, the calculated speed comes out to be artificially high, even faster than light. It is a geometric projection effect. The object is not moving faster than light. The news of its movement is just reaching us in a compressed time frame, creating the illusion of impossible speed. This illusion was a major puzzle for a while, but once it was understood, it became a useful tool. The fact that we see superluminal motion in a jet tells us two things. First, the material in the jet must be moving at a velocity very close to the speed of light relativistic speeds. Second, the jet must be oriented at a very small angle to our line of sight. This helps us understand the physics of these powerful black hole jets and how they are structured. So what started as a paradox, a seeming violation of the fundamental laws of physics, turned into a clue. The mirage of faster-than-light travel was actually a signpost pointing to the extreme nature of the engines that power these distant, brilliant quasars. It is a reminder that in the universe our perspective matters. Seeing is not always believing, especially when things are moving at 99.9% of the speed of light. Number 9, those first alien signals were just a spinning corpse star. In 1967, a graduate student at Cambridge University named Jocelyn Bell Burnell was scanning the sky with a new radio telescope. She was looking for quasars. She noticed a strange signal. It was a pulse. It repeated with incredible regularity. The pulses came every 1.337 seconds. They were so precise that you could set a clock by them. The signal was too fast and regular to be a quasar or a normal star. It was so strange and artificial sounding that the research team half-jokingly nicknamed it LGM-1. LGM stood for Little Green Men. For a brief time, they seriously considered the possibility that they had discovered a signal from an alien civilization. An alien beacon flashing across the galaxy. They kept this a secret. They did not want to cause a panic or a media frenzy until they knew what they were dealing with. Belle Burnell kept searching the sky. Soon she found another similar signal coming from a different part of the sky. Then a third and a fourth. It became clear that these were not alien signals. It would be too much of a coincidence to find 4 separate alien civilizations all broadcasting with the same kind of technology at the same time. This had to be a new natural type of astronomical object. The object was a pulsar. The illusion of an artificial signal was created by a natural phenomenon that just happened to mimic a beacon. A pulsar is a type of neutron star. A neutron star is the incredibly dense collapsed core of a massive star that has exploded as a supernova. It is a city-sized ball of matter so dense that a teaspoon of it would weigh billions of tons. Many of these neutron stars are spinning incredibly fast. Some rotate hundreds of times per second. They also have extremely powerful magnetic fields. These fields create beams of radio waves that shoot out from the star's magnetic poles. Now, if the star's magnetic poles are not aligned with its rotational axis, these beams of radiation will sweep across the sky like the beam of a lighthouse. If one of these beams happens to sweep across the Earth, our radio telescopes will detect a pulse of radio waves. Then the beam sweeps past and the signal disappears. Then the star rotates around and the beam sweeps past us again. We see another pulse. The time between pulses is the rotation period of the neutron star. This is why the signal is so incredibly regular. It is governed by the stable spin of a super-dense object. So the little green men were actually the spinning corpses of giant stars. The discovery of pulsars was one of the most important astronomical finds of the 20th century. It was the first confirmation that neutron stars, which had been theorized in the 1930s, actually existed. It opened up a new field of physics, studying matter under the most extreme conditions imaginable. The Nobel Prize in Physics was awarded for this discovery in 1974 but it was awarded to Bell Burnell's supervisor, Anthony Hewish, and another astronomer, Martin Ryle. Jocelyn Bell Burnell, the student who first found the signal and argued that it was real, was left out. This has been a source of controversy ever since. The story of the first pulsar is a story of a cosmic illusion that briefly made us think we were not alone, and a human story about who gets credit for a monumental discovery. Number 8. The biggest things in the universe are mostly nothing. The universe is not uniform. On the largest scales, galaxies are arranged in a vast web-like structure. This is called the cosmic web. It is made of dense filaments of galaxies and dark matter, which connect at massive nodes, which are the galaxy clusters. But in between these filaments and clusters, there are enormous regions of space that are almost completely empty. These are the cosmic voids. They are the biggest things in the universe. The Boots void, discovered in 1981, is one of the most famous. It is about 330 million light years in diameter. If our Milky Way galaxy were at its center, we would not have known about the existence of other galaxies until the 1960s. The space inside is that empty. The illusion of the voids is that they are true nothingness. But they are not. They are not a perfect vacuum. They just have a much lower density of matter than average. They probably contain some very small, faint galaxies, and they are certainly filled with dark matter, just at a much lower concentration than in the filaments. They are also filled with dark energy, the mysterious force that is causing the expansion of the universe to accelerate. In fact, because the voids are so empty of matter, they are the places where the effects of dark energy are most dominant. Inside a dense galaxy cluster, gravity is winning. But inside a void, dark energy is winning. The voids are actually getting bigger over time, pushing the filaments and clusters farther apart. Voids trick us in other ways. In 2004, astronomers studying the cosmic microwave background CMB, the afterglow of the Big Bang, found a huge cold spot. It was a region of the sky that was slightly colder than the average temperature. This was a major puzzle. One leading explanation is that this CMB cold spot is caused by a massive supervoid. A void this large, located between us and the CMB, could cause this cold spot through something called the integrated Sachs-Wolf effect. As light from the CMB enters the void, it gains energy. As it leaves, it loses energy. Because dark energy is stretching the void while the light is passing through, the light loses more energy on its way out than it gained on its way in. This makes it appear slightly cooler or redshifted, so this giant empty space could be creating the illusion of a cold spot on our map of the baby universe. Studying voids is crucial to understanding cosmology. Their size and distribution are very sensitive to the properties of dark energy and dark matter. By mapping out the cosmic web, including the empty parts, we can test our models of how the universe formed and evolved. The voids are the scaffolding around which the universe's structure is built. They are not just empty space. They are an active and essential part of the cosmos. They are a mirage of nothingness that actually holds the key to understanding the forces that shape everything. They show us that the most interesting parts of the universe are not always the bright, shiny ones. Sometimes it is the darkness in between that tells the real story. Number 7, the universe seems to have a preferred direction. The Big Bang Theory says that the universe should be isotropic. That means it should look the same in all directions. On the largest scales, there should be no special direction, no up or down in the cosmos. When we look at the cosmic microwave background CMB, the faint radiation left over from the Big Bang, it is incredibly uniform. The temperature is the same everywhere, to 1 part in 100,000. This is strong evidence for the Big Bang model. But when scientists used the MAP and Planck satellites to make extremely detailed maps of the CMB, they found some strange anomalies. things that should not be there if the universe is truly isotropic. The most famous of these is the axis of evil. This is a nickname for a series of unexpected alignments in the largest scale fluctuations of the CMB temperature. These large features, which stretch across the entire sky, seem to be aligned with each other. And more bizarrely, they also seem to be aligned with the plane of our own solar system, the ecliptic plane. This is a huge problem. It is like taking a photo of a random bumpy wall and finding that the biggest bumps just happen to line up perfectly with the angle you are holding your camera. It suggests that either it is a massive 1 in 1,000 coincidence, or there is something wrong with our data or our understanding of the universe. The illusion here could be a statistical fluke. The universe is a big place. Unlikely things can happen. It is possible that we just happen to live in a universe where the largest CMB features randomly lined up this way. Most cosmologists believe this is the most likely answer. They argue that when you look for patterns in a huge data set, you are bound to find some that look significant but are actually just noise. This is called the look elsewhere effect. Another possibility is that it is not a cosmic feature, but a local one. Perhaps there is some unknown error in our instruments, or some subtle effect from our own solar system or galaxy that we have not properly accounted for. This would explain the alignment with the ecliptic plane. Scientists have spent years trying to find such an error, but they have not been able to. The anomaly persists in the data from 2 different satellites, WMAP and Planck, which makes a simple instrumental error less likely. The most exciting and most unlikely possibility is that the universe is not actually isotropic. Maybe there is a special direction in the cosmos. This would require a radical rethinking of modern cosmology. Some exotic theories involving things like cosmic strings or alternative models of inflation could potentially produce such an alignment. But there is no other evidence to support these ideas. The axis of evil is a cosmic mirage that sits right at the edge of our understanding. It is a hint that something might be wrong, but we do not know what. It could be an illusion of significance and random noise. It could be an illusion created by our own local environment, or it could be the first crack in our standard model of the universe, a hint of new physics that we have not yet discovered. For now, it remains one of the biggest and most troubling puzzles in cosmology, a cosmic Rorschach test that might be a meaningful pattern, or might be nothing at all. Number 6. We see faces and skulls in the clouds of creation. In 1995, the Hubble Space Telescope took one of its most famous images. It was of the Eagle Nebula. It showed 3 gigantic pillars of gas and dust. Inside these pillars, new stars were being born. The image was nicknamed the Pillars of Creation. It is a stunning picture, and many people, when they look at it, see shapes. They see figures, animals, or other familiar objects in the swirling clouds. This is a psychological phenomenon called pareidolia. It is the tendency of the human brain to perceive a familiar pattern, like a face, in a random or ambiguous stimulus. It is why we see a man in the moon or animals in the clouds. The cosmos is full of these illusions. There is the Horsehead Nebula, a dark cloud of dust that looks uncannily like the head of a knight in a chess set. There is the Witchhead Nebula, which looks like the profile of a classic cartoon witch. More recently, a structure nicknamed the Hand of God was imaged by NASA's NuSTAR X-ray telescope. It is a pulsar wind nebula that looks like a giant, ghostly hand reaching through space. There is the Skull Nebula, which looks like a skull, and the Eye of God Nebula, the Helix Nebula, which looks like a giant eye staring at us from across the cosmos. These shapes are, of course, complete coincidences. They are mirages created by our own minds. The nebulae are vast, 3-dimensional structures of gas and dust, sculpted by the radiation and stellar winds from hot young stars. We are seeing them from one specific angle, from our vantage point on Earth. If we could fly around to the other side of the Horsehead Nebula, it would not look like a horse at all. It is a trick of perspective, but while the shapes themselves are an illusion, they are not meaningless. They tell us about the complex and often violent processes that are happening in these stellar nurseries. The dark shape of the Horsehead is a dense cloud of cold gas and dust that is silhouetted against a brighter, glowing nebula behind it. The pillars of creation are being eroded and sculpted by the intense ultraviolet radiation from a cluster of massive young stars located just outside the image frame. In a few 100,000 years, the pillars will be completely gone, boiled away by this radiation. The Hand of God is the energetic aftermath of a supernova explosion where the rapidly spinning pulsar at the center is blowing a bubble of high-energy particles into the surrounding space. So these cosmic illusions serve a purpose. They draw us in, they make these distant, abstract objects relatable and memorable. The name Pillars of Creation is much more evocative than its official designation, M16. These names and shapes are a bridge between the cold, hard science of astrophysics and the human experience of wonder and pattern recognition. They are a reminder that when we look at the universe, we are not just passive observers. We are bringing our own brains with all their quirks and biases to the act of observation. The face we see in a nebula is not really there, but the sense of awe it inspires is very real. It is a collaboration between the universe's random beauty and our brain's relentless search for meaning. Number 5, that distant planet we found might not be a planet at all. You know, in the last 30 years, we have discovered thousands of planets orbiting other stars. These are called exoplanets. Finding them is incredibly difficult. They are very small and faint, and they are lost in the glare of their parent star. Most exoplanets are found indirectly. One of the most common methods is the transit method. This is what the Kepler Space Telescope used. It stares at a patch of stars, looking for tiny periodic dips in their brightness. If a planet passes in front of its star from our point of view, it will block a small amount of the starlight, causing a dip. If this dip repeats on a regular schedule, it is a strong candidate for a planet. But this method is full of potential illusions. There are many other things that can mimic the signal of a transiting planet. These are called false positives, and they trick our telescopes all the time. One of the most common false positives is an eclipsing binary star system. This is a system of two stars orbiting each other. If the system is far away, our telescopes might see it as a single point of light. If one star passes in front of the other, it will cause a dip in the total brightness. This can look exactly like a planet transit. Sometimes it is a big star being eclipsed by a smaller star. Other times it is a faint binary system that happens to be in the background, aligned with a brighter foreground star. The faint binary's eclipse gets blended with the light of the foreground star, creating a small dip that looks like a planet. Another source of false positives is star spots. Stars are not perfect uniform balls of light. They have cooler, darker spots on their surface, just like our sun has sunspots. As the star rotates, these spots can move into our view and then out of it. This can cause the star's brightness to vary in a periodic way. If a large star spot takes about the same amount of time to rotate across the star's face as a planet would take to orbit, it can create a signal that is very difficult to distinguish from a real planet. Astronomers have to do a lot of follow-up work to confirm a planet candidate. They use ground-based telescopes to look for other signs. For example, they can use the radial velocity method, which looks for the tiny wobble in the star's motion caused by the gravitational pull of an orbiting planet. If they see both a transit and a radial velocity signal, they can be much more confident that it is a real planet. They also use high-resolution imaging to check for background binary stars. The process of finding exoplanets is a process of peeling away layers of illusion. The first signal is often a mirage. The Kepler mission, for example, found thousands of planet candidates, but only a fraction of them have been confirmed as real planets after careful vetting. It is a cosmic game of cat and mouse. The universe presents us with a signal, and scientists have to use every tool they have to figure out if it is the real thing or just another clever trick. Every confirmed exoplanet is a victory against cosmic deception. Number 4, the entire universe might be a hologram. This is perhaps the most mind-bending illusion of all. The idea is that the three-dimensional universe we experience might be a projection. It could be a hologram. The real information that describes everything in the universe, including us, could be stored on a two-dimensional surface at the universe's boundary. This is called the holographic principle. It sounds like science fiction, but it comes from some of the most advanced thinking in theoretical physics, particularly in the study of black holes and string theory. The idea started with black holes. In the 1970s, Jacob Bekenstein and Stephen Hawking discovered something strange about them. They found that the amount of information a black hole can hold its entropy is not proportional to its volume, as you would expect. It is proportional to the surface area of its event horizon, the two-dimensional boundary from which nothing can escape. This was a shocking result. It is like finding that the amount of data you can store on a hard drive depends on the area of its casing, not the volume of the disk inside. It suggested that somehow all the information about the three-dimensional stuff that fell into the black hole is encoded on its two-dimensional surface. Physicists like Gerard Hooft and Leonard Susskind extended this idea to the entire universe. They proposed that the whole universe could work the same way. The holographic principle states that the description of a volume of space can be thought of as encoded on a boundary to that region. For our universe, this boundary would be a distant two-dimensional surface. The 3D world we see and touch would be a projection of the physical processes happening on that surface. What does this mean? It does not mean we are living in a computer simulation, though, that is a related idea. It is a statement about the nature of information and reality itself. It suggests that space and volume might be an illusion, an emergent property of something more fundamental. One of the biggest challenges in physics is to unite Einstein's theory of gravity general relativity with quantum mechanics. The holographic principle is a powerful tool in this search. It provides a way to connect a theory of gravity in a certain number of dimensions to a quantum field theory without gravity in one fewer dimension. This is a huge theoretical breakthrough. Is there any evidence for this? Not directly. It is very hard to test, but in 2017, a team of physicists published a paper showing that some observations of the cosmic microwave background are consistent with the holographic model. This is not proof, but it is a hint that the idea is not crazy. Another idea is that if we live in a hologram, there might be a fundamental limit to the amount of information that a region of space can contain. This could show up as a kind of holographic noise or graininess to space-time itself. Experiments at Fermilab have been trying to detect this noise, so far without success. The holographic principle is the ultimate cosmic illusion. It suggests that the very dimensions of our reality might be a mirage. We perceive a rich 3D world, but the fundamental reality might be a flat 2D information structure. We might be the characters in a story written on the edge of the cosmos. It is a humbling and profound idea that pushes the limits of what we mean by real. Number 3, a quasar's brightness is a century-long deception. And quasars are the brightest continuous sources of light in the universe. They are the active cores of young galaxies powered by supermassive black holes feeding on enormous amounts of gas and dust. They can be 1 trillion times brighter than our sun. Because they are so bright, we can see them from across the entire observable universe. This makes them incredibly useful as standard candles to measure the expansion of the universe and probe the dark matter that lies between them and us. But there is a problem. They are not standard, their brightness is not constant. It varies, and this variation is an illusion that has fooled astronomers for decades. The light from a quasar is not a steady beam. It flickers and varies over time. This is because the accretion disk, the swirling disk of matter falling into the black hole, is a chaotic and turbulent place. Flares and instabilities in the disk cause the brightness to change. This intrinsic variability is a nuisance, but it is understood. The real illusion comes from something else, gravitational microlensing. As the light from a distant quasar travels towards us, it passes by countless stars in the galaxies that lie between us and the quasar. Each of these individual stars has its own gravity. This gravity can bend and focus the quasar's light. It acts as a small moving lens. As these stars drift across our line of sight to the quasar, they can cause its apparent brightness to magnify for a period of time. This is microlensing. The effect is that the quasar's brightness seems to wander up and down randomly over years and decades. This is not due to any change in the quasar itself. It is an illusion created by the millions of invisible, moving stars in a foreground galaxy. It is like looking at a distant streetlight through a bumpy, warped piece of glass. The light will seem to flicker and shimmer, not because the streetlight is changing, but because the lens in front of it is. This was a huge problem. If we cannot trust the brightness of a quasar, we cannot use it for many cosmological measurements. It also made it hard to study the quasars themselves. How could you tell if a change in brightness was intrinsic to the quasar or just a microlensing event? For a long time it was a mess, but recently astronomers figured out how to turn this illusion into a tool. By studying the precise way a quasar's light flickers due to microlensing, they can learn about the quasar itself. The accretion disk of a quasar is far too small to be imaged directly, even with our best telescopes. It is a tiny dot inside a tiny dot, but microlensing allows us to probe its structure. A smaller part of the disk will be magnified more strongly by a star than a larger part. By watching how the quasar's color changes during a microlensing event, we can actually measure the size of the disk at different wavelengths. They have found that the part of the disk emitting X-rays is much smaller than the part emitting visible light, which is exactly what theories predicted. So this cosmic mirage, the century-long deception of a quasar's brightness, has become a unique microscope. We are using the gravity of individual stars billions of light years away as a natural telescope to resolve details in an object that is trillions of times more distant. It is a beautiful example of how, in astronomy, a problem can be turned into a solution, and an illusion can be used to reveal the truth. Number 2, the emptiness of deep space is an optical illusion. We are told that space is a vacuum. Between the stars there is nothing, but this is not true. The interstellar medium is filled with gas and dust, and this medium creates a powerful illusion. It is the illusion of emptiness and transparency. In reality, space is more like a thick fog. It is a fog that obscures our view of 90% of the stars in our own Milky Way galaxy. The center of our galaxy is about 26,000 light years away. It is a place of incredible activity. There is a supermassive black hole there, Sagittarius A. There are millions of stars packed into a very small region. It should be the brightest part of our night sky. It should outshine everything. But we cannot see it. Not in visible light. If you look at the Milky Way in the sky, you will see a bright band of stars. But running down its center is a dark rift called the Great Rift. This is not a lack of stars. It is the opposite. It is a series of gigantic overlapping clouds of interstellar dust that are blocking the light from the billions of stars behind them, including the galactic center. This is interstellar extinction. The same dust that causes reddening also just blocks light completely. It makes distant objects look dimmer than they really are. For centuries, this fooled astronomers. In the early 20th century, Harlow Shapley was trying to map the size and shape of our galaxy. He was measuring the distances to globular clusters. He found that they were centered around a point far away in the direction of Sagittarius. He correctly concluded that this was the center of the galaxy, but he got the size of the galaxy wrong. He thought it was smaller than it is, and that the sun was farther from the center than it is. This is because he underestimated the effect of dust. The dust made the distant clusters look fainter, so he thought they were closer than they really were. The illusion of empty space was only broken when we started building telescopes that could see in other wavelengths of light. Radio waves and infrared light can pass through the dust. When radio astronomers pointed their telescopes at the galactic center, they found an incredibly bright source. When infrared astronomers did the same, they saw millions of stars that had been completely invisible before. The James Webb Space Telescope, with its powerful infrared vision, is revolutionizing our view of these dusty regions. It is peeling back the curtain of the Great Rift and showing us the stellar nurseries and the chaotic environment around the galactic core in stunning detail. This illusion affects our view of the entire universe. When we look at distant galaxies, we are seeing them through the dust in our own galaxy and through the dust in theirs. We have to correct for this dimming effect to get an accurate measure of their true brightness and distance. The universe is not a clear window, it is a dusty, smoky room, and for most of human history we were staring into the smoke, thinking it was emptiness. It is a profound reminder that what we see is not what is there. The cosmos has a veil, and we have only just learned how to lift it. Number 1, almost all of the universe is an invisible mirage. The biggest illusion in the entire cosmos is the one we are living in every day. It is the illusion that the world is made of the stuff we can see, the atoms, the stars, the galaxies, the planets, you and me. All of this normal matter, called baryonic matter, makes up less than 5% of the total mass and energy content of the universe. The other 95% is a complete mystery. It is a mirage. We cannot see it. We cannot touch it. But we know it is there because we can see its effects. This is the illusion of dark matter and dark energy. About 27% of the universe is dark matter. The evidence for it is overwhelming. In the 1930s, Fritz Zwicky was studying the Coma cluster of galaxies. He measured how fast the galaxies were moving. They were moving so fast that the gravity of the visible matter in the cluster was not nearly enough to hold them together. The cluster should have flown apart. He proposed that there must be some invisible Dunkel materie or dark matter providing the extra gravitational glue. No one believed him for decades, but in the 1970s, Vera Rubin found the same problem inside individual galaxies. She measured the rotation speeds of stars in the Andromeda Galaxy. Stars at the outer edges were orbiting just as fast as stars near the center. This violates Newton's laws of gravity. If the visible matter was all there was, the outer stars should have been moving much slower. The only way to explain this is if the galaxy is embedded in a massive, invisible halo of dark matter. We see its effects everywhere. We see it in the gravitational lensing of light around galaxies. We see it in the structure of the cosmic web. We see it in the temperature fluctuations of the cosmic microwave background. The evidence is solid, but we have no idea what it is. It is not just normal matter that is dark, like a planet or a black hole. We have looked for that. This is something new. It is a new type of particle, not part of our standard model of particle physics. Scientists have built huge sensitive detectors deep underground, trying to catch a dark matter particle as it passes through the Earth. So far, they have found nothing. Dark matter is a ghost. It is the invisible scaffolding upon which our visible universe is built. The other 68% of the universe is even stranger. It is dark energy. This is the name we give to the mysterious force that is causing the expansion of the universe to accelerate. In the 1990s, 2 teams of astronomers were using distant supernovae to measure the expansion rate of the universe. They expected to find that the expansion was slowing down due to the gravitational pull of all the matter. Instead, they found the opposite. The expansion is speeding up, something is pushing the universe apart. We call this something dark energy. We do not know what it is. It might be a property of space itself, a cosmological constant, as Einstein once proposed. It might be a new type of energy field that fills all of space. We have no good answers. So this is the ultimate cosmic illusion. We look out at the sky with our powerful telescopes and we see a universe of breathtaking beauty and complexity. But we are only seeing 5% of the picture. The real universe, the one dominated by dark matter and dark energy, is completely invisible to us. It is a cosmic ocean, and our visible world is just the foam on the surface. We are living inside a mirage, a trick of perception that makes us think that our reality is the whole reality. The quest to understand dark matter and dark energy is the biggest challenge in modern science. It is the quest to see behind the greatest illusion of them all.